Let's go ahead and multiply 13 base 4 by 21 base 4. So the first step is to write it this way using more or less our standard algorithm, but also what we have to do is make a multiplication chart. So it's in base 4, so we have to go, I guess we could add the zeros, but we have to go up to 3. 0 times 0 is 0. And I guess all these are zeros. 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, and the same over this way. 2 times 2 is 4, but 4 is 1, 0 in base 4. 3 times 2 is 6, but 6 is 4 and 2, but 4 is 10, so 10 plus 2 is 12. These are both the same. 3 times 3 in base 10 is 9 things, but 9 things is made up of 2 4s and a single. So that's how we come up with that table. So then 3 times 1 is 3, 1 times 1 is 1. 3 times 2 is 6, except 6 is what we get in base 10. We see over here when we multiply 3 by 2, we get 12 in base 4. So we write down the 2 and carry over the 1. 2 times 1 is 2, plus 1 is 3. So this is 3, 3, 3. And that's what we get. Because this is a relatively easy problem, I think it's worth thinking about some things. Notice, obviously, with 3 times, just starting over, 3 times 1 is 3. But 1 times 1 is actually 1 times 1, 0, and base 4. But that would be 1 times, now if it's in base 4, that's 1 times 4 plus 0 times 1. Now, I'm moving over to base 10. This is 1 times 4 things, because this goes away. And so that's a 4 in base 10, but a 4 in base 10 is 1 times 4 plus 0 times 1, which leads me to 1, 0, 1, 0. So that is one explanation for why 1 times 1, when we multiply these two, you get a 1 here. It's not really a 1. It's a 1, 0, it's a 10. Now let me go ahead and do the same thing for 2 times 3. It's actually, and just to follow the same order, it's 20 times 3. But that's 20 base 4. So that would be 2 times 4 plus 0 times 1 times 3. Now that would be 8 things in base 10. times 3 things, or 8 by 3. That's 24 things, so we kind of move over to base 10 over here. Move over to base 10. And then we're going to move back to base 4 because 24 things is blank times 16 plus blank times 4 plus blank times 1. These are the place value of each digit in base 4. So 24 things, there's 116 that fits. And we take 24, take away 16. Let's see how much we have left over. It's 8, which means we need 2 of these. And so, and none of these. So it's a 1, 2, 0 in base 4. And that's why we get this 2 here. That's this 2. And we raise the 1, which is this one here. And then the last thing, and I'm running out of space, so I'm going to come up here. Let me use red. It's a 20 times a 10. So 20 times 10, because 2 times 1 is really 20 times 10. Now, and these are in base 4. Now 20 base 4 is 2 times 4. If you want the other digit, it's 0 times 1. And we're multiplying that by 1 times 4 plus 0 times 1. So it's 8 things. And I'm using my base 10 because it's easier for me to refer to that and relate to that, times 4, which is 32 things. But 32 things back to base 4 is blank 16 plus blank 4 plus blank 1. 16 is 2 of these, none of these other ones. So it's 2, 0, 0. So 2 times 1 is 2, 0, 0. But I have to add this 1 plus 1, 0, 0. And that's how we get the 3, 0, 0. And that's where this 3, that I had changed colors. Just realized it didn't. That's okay. This is 3, 0, 0 because it's in this digit. Anyway, you still get the same answer, but it explains more of why it works as opposed to just doing the process. And so that's why I try to give you a little more explanation with a slightly easier problem if you use just the basic standard algorithm. But it becomes a little more complicated if you look at the conceptual aspect of it, but it also explains more.